basic two-dimensional geometric transformations. In that, we'll discuss two-dimensional scaling. In this context, you see I have considered P, Q, R as 4 points, and because of scaling, and this P has been shifted to P dash, and corresponding Q has been shifted to Q dash, and correspondingly, and therefore you can see the whatever the solid lines I have given a polygon, and that has been converted to another polygon due to scaling. And but here you can see I have considered 4 points, but we'll discuss only for a single point. Therefore you can see here, and for scaling, if the scaling is here, Sx is the scaling factor, and x is the original coordinate, and x dash is the after scaling, the x dash is the coordinate, and where already I told x is the scaling factor in the x direction, and sy is the scaling factor in the y directions, and in the homogeneous coordinate matrix form, and that we can express this is the transformation matrix, and this is the original coordinate, and therefore if you multiply that, you will get that transformed coordinates. And if you multiply these two matrices, you will get it. You can see Sx is multiplied with x, and both are 0 0, therefore it will be 0, therefore x dash should be equal to s in x into Sx. Therefore this matrix is nothing but this corresponds to these two equations. And then we will take an example here. You can see here I have taken a 4, again I have taken a 4 coordinates, and this after scaling transformation, and this coordinates P has been shifted to P dash, and Q has been shifted to Q dash, R has been shifted to R dash, and S has been shifted to S dash. And here I have taken the scaling factor in the x direction is 0.5, and y direction also scaling factor is 0.5, and these are the coordinate I have shown here. These are the original coordinates. After scaling operation is applied, that you can see x coordinate of P will be multiplied by 0.5. It has become 50, and 100 has become 50 because we are multiplying by 0.5. Therefore this point has been, its coordinate is 100 and 100, 100. Now it has become 50, 50. Exactly in the similarly, if you scaling operation apply to the Q, that is you multiply by the 200 by 0.5, it has become 100, and 100 is multiplied by 0.5, it has become 50. Therefore Q dash coordinate is now 100, 50, but whereas Q is 200, 100. In that way, all these points I have taken a 4 point so that a polygon can be formed, and how the polygon is scaled into a, and here scaling is less than 1, therefore from this final polygon is smaller than the original polygon, and that is the scaling. Now we'll discuss two-dimensional scaling about fixed point. What does it mean? First we have to understand. That means there is a point where I am, this point here in this case it is been denoted by xf, yf, and that point will not be moved from, it will remain fixed. It will remain fixed after scaling. That means, what does it mean? This is the solid lines. This I have shown in a triangle here with the solid lines, and in that triangle, this x7 and yf is this point. After scaling, that triangle has become, that I have dashed line I have become, it has been reduced. The triangle has become scaled, and triangle size has been reduced. But that point, this point remained at its original position. That means two-dimensional scaling about a fixed point. That is the meaning of that. And then we can find the coordinates of a particular point after the scaling. That means x dash is the point after the scaling operation, and that by this equation we can find this what is the transformed coordinate of x coordinate after the scaling. Exactly in the similarly y coordinate after the transformation, we can find the y coordinate also here by this equation. Now I shall go for how you can express in the homogeneous coordinate matrix form. In this case, homogeneous matrix form will be a bit complicated. Here we have to have a procedure to do that. Now first what you have to do, I have written the translate the object so that the fixed point is origin, and scale the object. Then you scale the object about the origin and translate so that the fixed point returns to the original position. That I am showing in the diagrammatical form, then it will be very clear. Again I repeat, this is we are doing to do in the homogeneous coordinate form matrix form. In homogeneous matrix we have to do, then this procedure has to be adopted. Now I am showing the whatever I have written here, case 1, 2, 3, that I am diagrammatically I am showing here. Now first this is an object and that is the fixed point, and then now my fixed point is moved to the origin here and along with the object, and then transformation happened. You can see it is a bigger size, now it is a smaller size. Then after that transformation is completed, then we move the fixed point to its original position. That is the procedure. Now in the homogeneous coordinate form, therefore 3 matrices will be there. The first matrix, you can see the first matrix here, transformation matrix, it is the translation is happening. It is we are moving from original xf and yf to this matrix, we are moving to the origin. Then in this we are scaling. After that we are scaling. Then we are in this matrix, we are moving it back to its original position, and that is the original coordinate of that point. And then if we one by one, if we multiply, we get this matrix, and then this matrix is multiplied with this matrix. Therefore you can see the homogeneous matrix. What is the advantage? You can see there are 3 matrices are there, and we after multiplication we convert it into a single matrix, and that is called transformation matrix. And only for showing that I have shown here, if you multiply the original x coordinate, you will get the x dash. This is the x dash. This means after transformations, after the scaling transformation, this is the x dash coordinate. This is the y dash coordinate. And as I shown in the equation also, equation number 3 and 4, it gives the after multiplication in the matrix we are getting the same thing also. That I wanted to show here. Therefore this is the x dash and this is the y dash, and that is all about the scaling of 2-dimensional scaling.